Hello students, how are you? I hope you are doing well. And today I have come with three questions based on current electricity, which were asked in the second shift or the afternoon shift of 24th January 2023 JEE mains. So without wasting time, let us discuss the first question. See, the first question is, just a minute, student. Yeah, a cell of EMF 90 volt, a cell of EMF 90 volt connected across series combination of two resistors each 100 ohm resistance. A voltmeter of resistance 400 ohm is used to measure the potential difference across each resistor. The reading of the voltmeter will be. See, the reading of voltmeter means the voltage appearing across the voltmeter. Similarly, the reading of an ammeter means the current flowing through the ammeter. These are very simple things you should understand. So, the moment the voltmeter is connected across the resistor to measure the voltage, the overall resistance will change. So, obviously, the voltage appearing across the voltmeter will also change because of the resistance of the voltmeter itself. So, basically, we have to calculate the voltage appearing across the voltmeter, which will be the reading of the voltmeter. So, let us draw a simple diagram here. So, these are the two resistors, 100 ohm each. 100 ohm each. They have been connected to a cell of 90 volt. This was the initial situation. Now a voltmeter having a resistance of 400 ohm, 400 ohm is connected. So this is a voltmeter. So we have to calculate the voltage appearing across these 2 points. Let us name them as A and B. So it's very simple. Let us calculate the equivalent resistance because these two are in parallel, you can say. Since these two are in parallel, so equivalent resistance you can obtain as product upon sum. So product upon sum. So 100 5s are 580. So 80 ohm is the equivalent resistance. So the diagram now becomes something like this. Okay. This side you have 100 ohm, whereas this side you have 80 ohm. So this 90 volt will be distributed in the direct ratio of the resistances, isn't it? Because in series, see, in series current remains same, therefore the voltage drop across each resistor will be in the direct ratio of the respective resistances. Now what is the ratio of resistances? 80 is to 100 means 4 is to 5. This is the ratio. So the voltage appearing across this, which is also the voltage appearing across the voltmeter, will be the required voltage will be this 90 volt will be distributed in the ratio 4 is to 5. So 4 is to 5. So this will be 10 into 4, that is 40 volt. Okay. So this is 40 volt is the correct answer. Right. Then let us move to the next question, please. The second question. This is the second one. If a copper wire is stretched to increase its length by 20%, the percentage increase in resistance of the wire is. Now here we have to assume that the copper wire is stretched uniformly so that the volume remains unchanged. Mass or volume remains unchanged. So accordingly we can find. So now you see resistance of a prismoidal structure is rho L by A, and here we have been given that the increase in length is 20%. So basically we have been informed about the change in length. So we can replace area as volume upon length, because for a prism we all know that the volume is length into cross sectional area. Length into cross sectional area. This is the volume. So cross section area can be written as B by L. So we have rho L square by B. Now since rho and B are constants, so we can write resistance is proportional to square of the length. So when a wire is stretched uniformly, the resistance varies directly as the square of the length. Okay. So the new resistance upon original resistance is the new length upon original length whole square. Now the new length is 120 times of 120% of the original length. So we can write it as 1.2 times of the original length. So this is 1.44, isn't it? So since the new resistance is 1.44 times the original resistance, therefore the percentage increase is 44%. Percentage increase is 44%. So the correct answer is 44%. 1.44 times means what? 1 means initial value is already 1 time, and another 0.44 times means 44% is the increase. Then let us move to the third question. You can see three identical resistors with resistances R equal to 12 ohm it should be, I guess, 12 ohm, and two identical insulators with self-inductance. This is self-inductance. Self-inductors L equal to 5 millihenry are connected to an idle battery of this much as shown. The current to the battery after a long time when the switch has been closed. Okay. Now see students, these kind of questions are very simple to handle. When it is given that the after a long time when the switch is closed, that means what happens, there is a property of inductance. Inductance offers zero resistance after a long time when the connections are established. Inductors have a special property that they offer practically zero resistance to the circuit. So basically what we can do is we can simply short circuit the inductors. So when we short circuit the inductors, you'll observe that all the three resistors are in parallel basically. So the equivalent resistance will be R by 3. So the current through the battery will be voltage of the battery upon the total resistance between the cell terminals. So value of R is how much? 12. So you have 3 amperes. So correct answer is 3 ampere. Okay. So we'll stop here students. I hope you are liking my way of teaching. If you have any queries, you can ask me in the comment section. Okay. Kindly subscribe to my channel and also hit the like button. Thank you so much.